Welcome everyone to today's webinar, Java meets Generative AI, Build a Knowledge Management System with Spring AI. My name is Nikki Chen. I'm a Marketing Event Manager for the Developer Initiative here at Oracle. And today we're so excited to guide you through the process of leveraging Java, Spring Boot, and the innovative Spring AI APIs to create the next generation applications. We have also set up a Slack channel, Oracle AI ML services, in our developer workspace that you can access at the QR code or at the link on the screen. This channel will remain open after the event for you to contact us directly whenever you have any questions. And before I pass it off to the presenters, I wanted to let you know we have more upcoming events just like this one. You can check them out either with a QR code or the link in the chat. Today's webinar will be presented by Corrado Dibori and Nacho Martinez. Without further ado, I'll pass it to Corrado.
Okay, perfect. Thank you. And first of all, hello to everybody, and thanks for attending this webinar. I am Corrado Dibori, and I work in the Oracle Database Engineering as a developer and evangelist. Today, I'm going to talk about how you can embrace a generative AI project with Java, focusing mainly on Spring AI as a framework to use and build all the steps and components, and exploiting the new Oracle Database 23 AI that has vector store capabilities. We will see that as a Java developer, you have now all you need to implement a project based on generative AI. After the save of our mandatory slide, let's start reflecting about a thing. Do we really need Python to approach a generative AI project? Python has been quite popular so far as a main language to implement machine learning and deep learning projects, mainly for plenty of work frameworks that you can use to execute all the phases that normally are needed in a machine learning project, like data analysis, data preparation, training, validation, and testing. One of the most relevant capabilities has been provided by Python is through libraries like NumPy that are able to make multiplication of huge matrices that you need when you want to implement deep learning neural networks. But for Gen AI, the scenario is changing. Why? Follow me in the Retrieval Augmented Generation overview that explain which are the main pieces that you need to implement a generative AI project. Retrieval Augmented Generation is a methodology to avoid, first of all, fine-tuning of large language models to make able to answer questions related to your specific domain, to your specific data. Fine-tuning is quite expensive in general and must be run every time new data comes into in your knowledge base. So to implement differently Retrieval Augmented Generation, we have to implement, first of all, a data ingestion phase that is shown in this slide. Your documents could be wherever, into a vector store or into external storage. On this document, you have to perform chunking, a summarization, or both, in order to solve a main problem that large language model that provide vector index they have a limited number of text or bytes that you can provide. So in some way, your original document must be chunked or summarized in order to have something that is able to be provided to a language model for embeddings. Otherwise, everything will be cut if in excess of the context window. In this slide, you can see this component. These components are black boxes. The LLM embedded, you will ask for a service as a summarization that is also a LLM component, and chunking is performed through normal text manipulation. In the retrieval augmented generation phase, in the answering question, normally your question will go through the LLM embeddings to get the same kind of vector that has been stored into the vector store. And through a similarity search, you will find the nearest doc chunks in the vector store. Eventually, the question together with the top key chunks that we have retrieved will be provided to a re-ranker that is a sort of LLM models that is able to refit, reshape the list of chunks that have been provided by vector store similarity search. After that, you will add this list of chunks to the question and extra extractions for LLM to compose the response. And the prompt will be sent to LLM completion to provide the answer to the final user. What I've shown so far are services, black boxes, normally stateless, that you can call via REST service. And you can orchestrate a response in any kind of language that you want to use. And so we are going to talk about how to do this in Java. A main component of this process is the vector store, and the Oracle database has a tradition of ML capabilities since the older releases. But now with the 223 AI that has just been released, has been added also capability to memory Gen AI and the retrieval augmented generation with the vector store capabilities. It has been added the AI vector search feature to perform the similarity search that is important in this process. In order to enable a semantic search, let me say a sort of a not exact matching search, exploiting this vector that store semantic as a bunch of real numbers that represents the meaningful of the chunks or the question that you are providing to this system. So first of all, has been introduced a vector data type that allowed you to create vectors inside the normal table, providing the size and the type. But I suggest that to use a vector without any kind of constraints, because embedding models have different sides in terms of input and output. So the vector could change. Obviously, this kind of capability you can access through a normal JDBC driver that we have provided with the 23i that provide also the vector type. But what we do through this vector, you can perform a vector distance operation in which you specify the two vectors to compare and a distance metric that you can choose among 6 type of metrics that we provide, like Euclidean, cosine, and so on. With this capability, you can understand if what we have provided, for example, a tiger vector, is nearer to lion vector respect compared with an apple vector. In this way, you can retrieve from the database concept that you can use into the retrieval augmented generation that we have seen so far. But let me say, there are a lot of vector store in the market, and the implementation of vector type and distance, it's a sort of child play. But when you have to manage terabytes of knowledge, a raw metrics and a vector type is not enough. Because in chat, if you remind to the flow that I have shown at the beginning, the response will be the sum of the all steps that I'm shown in the previous slide. So it's quite time consuming. And you can't add a reasonable waiting time to retrieve just the chunks that you need to compose the prompting and provide to the final LLM. So it's quite important how much is quick the retrieval of this information. For this reason, we have introduced a different kind of search that is not an exact search, but how we call an approximate search. That is much quicker than a normal search, an accurate search. And you can provide for this vector index that could be based on graph that will go in memory. It is an high efficient way to find the chunks and the vector related. But you can also use a cluster based on partition. In this case, you have transaction support, and the data are stored into partition in database, so are safe in terms of crash of the system. So, but let's talk about to implement the rest of Gen. We have focused so far on Oracle database only, the vector store. On the market for Python are available LangChain and the implementation for Oracle AI of a vector store library. So you can use LangChain straight with the Oracle database. For Java, the main frameworks available are Spring AI and LangChain 4j, that is a porting from LangChain framework. But since that you need connection to database, I'll show in this presentation how to create for Spring AI and leverage the capabilities inside the Oracle database 23 AI. For both, you have the JDBC library that are able to provide to you the vector store and the other thing that we have seen into the database. Spring AI is a project into the ecosystem of Spring Boot. So if you are familiar with Spring, you will retrieve the same easiest tool to use in terms of create a project and start an Hello World. And this framework provides to you all the API that you need to create embeddings, leveraging any kind of LLM provided on the market. The chat completion, that is the final phase that you can run through OpenAI, Azure, and so on. And the vector database for all the most relevant database that are available on the market as a vector store. And I'll show you how to create on top of this an Oracle database implementation that you can provide a connection to plug into a RAG pipeline using Spring AI. So before to start, it's simple to create a connectivity with the Oracle database. Let me show how it is simple to create a Spring AI project with the Hello World that is provided out of the box. Has been added a new template that is named AI, and in this way, with the Spring CLI, you can create a Hello World that provides for you a project ready to run to wrap OpenAI services and create a microservice that call for you OpenAI with a controller REST endpoint that will do this work for you. After providing an environment variable for the OpenAI key that you have to retrieve before from OpenAI dashboard, you can run the application. Your application is ready to be called by a curl service, a curl request, sorry. Let me do a question regarding me, who is Corrado Lebari, and the response will be provided through OpenAI ChatGPT 3.5. That is, in this case, completely wrong. So now let's go on to the interface that you have to implement to call the vector database from Oracle. It's quite easy because you have to provide three methods. It's a sort of CRUD, so you have to provide another documents. Documents is the standard class to store a document into Spring AI. Delete and the similarity search. All the information we have to go into a table that you have to create in which you have to store this main information provided with the document that are the text, so the content of your chunks, the embedding vector generated by an embedding LLM models, and metadata related to the file, to the chunk that you want to store, sorry. And in terms of implementation, it's quite easier because you have to perform this insert to adding these three values. First of all, you have to get the content from the document, so you have a text value, and you have to store. And before to do this, you have to create the embedding vector. Through any of provider that are available on Spring AI. So you can choose whatever you need to perform the embedding operation. After that, you can leverage on the Oracle new vector type that we provide with JDBC and the Oracle type JSON that is already in place from the previous release. After this, the similarity search implementation is quite easier too, because you can choose in a select an order by the distant metric function that you can choose from Euclidean cosine Manhattan Helming similarity. And you will retrieve the first rows that are the nearest chunks compared with the embedding that you have provided here, so you can get the chunks needed to create a prompt. In terms of first phase, the ingestion, Spring AI already provides for you the capability to take a PDF in input, perform a chunking, a transformation into a text, providing, for example, how many pages you want to include into single documents. If we want to avoid the top margin of this document, and through the text splitter that you will provide through the PDF reader, the vector store accept the document already chunked and embedded by the add function that we have shown before. If you don't want to start from scratch, I prepared an example that will be provided soon on the Oracle AI Solution Hub that include all you need to start to use as a baseline to create a project that implements a generative AI application. Leveraging Spring AI API, first of all, Oracle DB 23 AI, Open AI embedding, but also local LLM running model for embedding and for also chat, the final chat. Using as sources PDF, and let me show the list of recent points that I have developed and I will provide through this demo. First of all, the store, a way to store a PDF that will be provided with a post request. Delete and the RAG. The RAG perform for you the embeddings of the question, retrieving with the similarity search the nearest chunks. And after that, you can store and provide to a chat completion model the engineered prompt, and you will get back the answer provided by chat AI, OpenAI chat. I also implemented some collaterals endpoints like store JSON in order to embeds JSON duality view in input that you have already created into the database, and store as embeddings and chunky that you can use to run similarity search. To understand which are the output from your question compared with the chunks that I have found into the RAG full pipeline, you can also ask for search similar that you provide to you the top chunks that have been found inside the database. And also eventually the embedding, and ask for a generate endpoint that is able to call straight the OpenAI service. So you can compare the difference between a response coming from a RAG pipeline respect an OpenAI generic request. So this is the kind of request that you can do. We provide a document, for example, and you can perform search similarity using this document and compare the results. But now let me share a video that will be explained by my colleague Nacho. Okay, Nacho?
Yeah. Thank you, Corrado.
You're welcome.
Yeah, so just as a refresher of what Corrado has been explaining, this is the architecture that we're working with. We have a Spring AI as the Java framework to interact with the code. Then we also have the new Oracle DB 23 AI as the storage system for our vector embeddings. We have OpenAI or Ollama compatible models. We will see why this is different and why it's important to have both options for all types of use cases. And here you can see how we are building the project with Maven. And you can see that it only takes like 4 seconds to build. And with Maven Spring Boot, we can start running the server, and this will generate an API in localhost, which we can then use to make calls in any programming language. So this is not only Java, but we have support for anything because we have published this as an API. So you can consume the data however you want. And just by running, Maven Spring Boot run, this is publicly exposed. You can put this on a OCI compute. You can put this locally on your computer, whatever you need in this case. And yeah, the demo application just takes like 2 seconds to run. We can make generations with GPT-4 Turbo, the GPT-4o after release, or any OpenAI compatible model that you can find, like the earlier ones. But this might be an issue for privacy related reasons, because if you don't want your data to be used by OpenAI, for example, here we can also choose to host with Ollama non-proprietary LLMs models like Llama 2, Llama 3, future models from Meta, and non-standard models like Mistral or any other. You can see here that you can also store PDF files or JSON files, and they are automatically converted into chunks and vector embeddings. And you'll be able to ask the LLM about the content of these files. And also, we will be able to inspect the vector embeddings individually, like here. So we can check the most similar vectors to the information present in the queries, and we can also get some information like the page number, the name of the file where that information was found. So it's very convenient that way. You can also, do this with the RAG endpoint. We just need to pass a message or a prompt, and the model will directly try to find the results first in the RAG system. And if it cannot find any information, then you can also customize what kind of response you will get from the model if it cannot find any of this information. This is, another example. To run the example and check if the database management system is working correctly. All these generations are made, first of all, going through the document, and if it cannot find anything, then this answer is also customizable. And we could also just ask questions that are not related to any document at all. Oh yeah, this is just the example that we saw before, where we can get some references from the embedded most similar vector found in the RAG system. So this would be kind of the response that we could expect. And this is the generate endpoint, which just allows us to make some calls to the original LLM without making any reference to the RAG system or any of the uploaded documents. So if we want, we could make, or we could have a filtering system between requests to the LLM that communicate with these live documents, and another way to ask simple questions with no additional file support. And of course, we will mention this at the end, but you have all of this that we're seeing today is available in a repository on GitHub, and you can go to oracle.com/AI solutions for all of them. But just to get back to you, Corrado, you can continue,
Okay.
and then we talk about this at the end if you want.
Okay. So let's return on a presentation, and then now let's talk about more about how to use a private model. As mentioned by Nacho, if your documents are private, thanks to an embedding models running outside your organization to get back the embeddings vector and store it into the database to perform then a research, and after that provide all this chunk again to another service to return the final answer. To avoid this external traffic of your data, it's possible to use local models. There are several providers, but one of the most famous that you will find inside Spring AI is represented by Ollama. Ollama is an organization that provides to you several models that you can interact, providing all the normal features that are required, parameters, sorry, that are required when you ask for a question to LLM. And you can run this as a server through Docker. And you can pull in this repository, in this case, embedding models or Llama 2 or whatever other, any other LLM available into Llama. How you can choose what you want to use? It's quite easy because you can go to the ollama.com library, and you will find any kind of models that are available. In our case, we have chosen, for example, Nomic for embedding. That is as these sites, and you can understand what are the features of this Nomic embedding. Clicking here, and you will see that as how many parameters need to run, the kind of quantization. The quantization represents the size of weight. So it's important to determine the size of GPU RAM that you want that you need to run this model. But probably you need to understand how is the performances of this model to compare with others. To do this, you can go to the Hugging Face leaderboard for MTBE, and you will find here a ranking of the top performer model. As you can see, there are quite huge models for embedding, 26 gigabyte with 7 billion parameters. But if you want to see how performs Nomic, it's quite easy. You look for Nomic, and you find that Nomic is a quite good ranking because it's 38 with only 137 million parameters. And if we want to compare, for example, for ADA, that is one of the famous embedding models provided by OpenAI, you can see that it's lower in terms of ranking in this benchmark site provided by Hugging Face. So you can choose any kind of model that is available on Llama, or eventually other servers that provide, like OpenLLM, that provide, for example, an OpenAI API. So you can use OpenAI API provided by Spring AI, setting the URL of your server and use it as a private model instead to use the original OpenAI service. So let me show through a video the process that we have implemented to start from the original application that we provide on GitHub through this demo, and how you can change the code in order to experiment an OpenAI full implementation, as shown at the beginning by Nacho. A mixed implementation with embedding through a private model and OpenAI as a service to provide the final answer, or eventually a fully private solution in which you run not only the embeddings model, but also the model to provide the chat. In this video, you can see that you can use Llama. We provide the procedure to create by yourself an OCI server to provide this as a service running on GPUs, with all you need to set up a GPU server that use actually this server. So after the first setup, you can enter into the GPU server to check if it's working Llama, and you can see that it's running like Llama as a service. And through logs, you can see eventually what is coming into this server. After that, you will check how is spread this workload into NVIDIA GPUs through this command, the NVIDIA SMI. You can see that Llama process is spread into these two GPUs that are on this kind of shape. So you can scale if you have more resources. You can run your model, larger model, up to, for example, 8 GPUs of A100 type. Another component is the Oracle database. You can run this through the container registry Oracle, and you can have without any credential through a Docker pool. So first of all, we check if the database is running. And now let's go inside what we can change into the code in order to transform this completely open So first of all, we have to import the Ollama embedding client that you can have through the starter that you have to include into the POM. So it's available from Spring AI, the Ollama Spring Boot starter. Through this, as usual in a Spring Boot application, you can use and inject all you need in terms of objects at runtime to use again the Ollama embedding as client and leaving the OpenAI chat standard interface. We have implemented three kind of controller for the free choices. In this case, is uncommented the embedding through Ollama and the OpenAI service. Into the vector service, you have to leave the import for the chat commented and change the OpenAI as a chat service. Finally, into the start of the demo application, you have to provide to the vector store your embedding reference in order to embed what you store as document into Oracle database 23 AI. In this way, you are leveraging something that is private, is in your own, and you can use with your data. After that, you can start the application, and you can test using the example that we have provided. In this case, we have dropped the table. You can choose through a file which kind of approach, if you want to drop or leave the same application, the same data. Through the same command that you have shown before, you can upload a document as an example that we provided to compare the results with the content of this PDF. And you can see after a while that to the LLM embedding server are arriving the chunks through a post API embeddings that are provided through the application that is chunking your PDF document per page, send to LLMs and get back the embeddings vector that will be stored together with this chunk inside the Oracle database. After the ingestion phase is completed, then you can move to test your application, asking, for example, which kind of database, which kind of database can be used inside this example. This question is related to the PDF that we have ingested, and you can see that only the embedding API has been called from this application, and the result will be use Oracle Autonomous Database or database for free. Just to look at the document. This is the document that we provide for example, and you can see that the question related to the database, again, I have it, so don't let me take time to this. Now let's turn to move in production this kind of application. I take this opportunity to introduce to you the Oracle Backend for Spring Boot. That is the natural, smooth last point of a Spring project, as in this case. Through this platform released for free, that provides for you in a few minutes an environment that hosts a Spring application using the Oracle database, like in this case. This platform installs for you a Kubernetes cluster tailored with all services that you need to deploy a Spring Boot application like this. like Eureka, admin, Spring config, and all observability stuff, and an API gateway to select a service to export outside your service, like RAG. Where you can run this platform on-premise, on Oracle Cloud Infrastructure, and eventually also on Azure. So you are free to deploy wherever you want. And how you will deploy the Spring Boot application that you have built through Spring AI. You have two opportunities, two choices, sorry. A command line interface that I'd show you into a quick demo, and a Visual Studio Code extension that you can plug into Visual Studio Code. And from there, you can browse the resources and upload and create a new application that you have developed locally. Through this platform, you can run Spring Boot application, leveraging an environment that is managed, and you can have this platform ready in a few minutes, for example, on OCI, through the marketplace on which you can, in which we can find the Oracle Backend for Spring Boot as a deployment through Terraform. And you will have an environment on which you can plug your application that will leverage several services that we provide as platform services. In the future, it's likely to have some capabilities related to AI, but it's under discussion. To move your application that you have developed through OpenAI, it's quite easy because it's in the example that we provide for Open. You have to set the OpenAI key, the OpenAI URL, the kind of models that you want to use for OpenAI, and for eventually text embedding through OpenAI services. The data source related to the database. If you want to drop the table, the vector table at the beginning, the kind of configuration of distance. And you can add also the where is the Olama URL service, and which kind of models used for embedding and for chatting. Let me show through a video how it's easier to deploy an application like this. On the right side, you can see Octant with a view of the cluster Kubernetes, in which have been deployed all the basic services of Oracle Backend for Spring Boot. Through the command line named Oracle ORCTL, you can access through the credential provided by the admin. After that, you can create the namespace that will hold the application, in this case RAG, without any fantasy. And at the beginning, we'll be injected the credential, the wallet to access the autonomous database, if you want to use eventually the autonomous database to store other data. After that, you have to simply provide the namespace, the name of your application, where is your jar file, the image version, and the profile that you need to run this application, in this case, production. As you can see, the file will be sent to the backend for Spring Boot. It will be created an image and registered into the container registry. And after that, this image will be used to create a pod that appear as demo AI into the console. And as you can see, you will have this service running in a few seconds inside a controlled environment. This service will be closed inside the Kubernetes until you open a route through OpenAI, through AP6 gateway. but you can open a direct link through a tunnel, and you can ask question to this service. In this case, it's empty, so no information meaningful will be provided by this service. Now let's jump on latest slide in which we will provide for you all you need to access the services, the demo on AI Solution Hub, how to create on OCI Marketplace Oracle Backend for Spring Boot, and our mail if you want to have any additional information. We are open to provide to you any kind of answer that you need to run through a generative AI project through Spring AI and Oracle Database 23 AI. Thank you. And
if you like today's session, we'd love to invite you back to check out our other upcoming events. We'd also love to hear your feedback and on what topic you'd like us to cover in the future. And hope to see you soon.